11 kilometers down, at the bottom of the Mariana Trench, the water is pressing in with a force of about 8 tons per square inch. That's roughly the weight of 50 jumbo jets, stacked directly on top of a single square inch of your body. A human dropped to this depth without protection wouldn't just die. They'd be gone in a fraction of a second, crushed past the point of even having a body left to recover. Every submarine ever built for this depth has to be engineered like a bomb built in reverse, designed entirely around not collapsing inward. And yet, at the exact bottom of this trench, in permanent freezing darkness, under more force than anything on the surface of the Earth will ever experience, something is alive down there. Not just surviving, hunting, feeding, reproducing, thriving, in the one place on this planet that seems built specifically to make life impossible. This isn't a place life adapted to. It's a place that should have made adaptation itself impossible, and something down there broke that rule anyway. This is the story of how that happens, and why almost everything you think you know about what life needs to survive is wrong. Act 1. Building the hostile world. To understand how extreme this place really is, you have to understand what happens to a normal object as it descends. For every 10 meters you go down in the ocean, the pressure increases by roughly 1 atmosphere. The same amount of pressure the entire weight of Earth's atmosphere puts on you right now, standing at sea level. 10 meters down, you've doubled that. 30 meters down, you've quadrupled it. This isn't a straight line that eases off. It keeps stacking deeper and deeper, all the way to the bottom of the deepest place on the planet, the Challenger Deep, at the southern end of the Mariana Trench, nearly 11,000 meters below the surface. By the time you reach that depth, the pressure has climbed to over 1,100 times what you're feeling right now. In practical terms, that's more than 16,000 pounds of force on every single square inch. It's the equivalent of an elephant's entire body weight balanced on your thumbnail. And pressure alone isn't even the strangest part of what happens down there. Because at that level of force, something happens to water itself that sounds more like science fiction than biology. Under normal conditions, water molecules link together in a loose, flexible structure. That's part of why water flows the way it does. But under the kind of pressure found at the bottom of the trench, that structure gets physically distorted. The water molecules themselves are forced out of their natural shape. And when that distorted water is inside a living cell, it interferes with the basic chemical processes that keep that cell alive. At extreme depth, water, the exact substance every living thing on Earth is built from, becomes actively hostile to life just by being compressed. That's one layer of the problem. Here's the second: light. Sunlight in the ocean fades fast. By around 200 meters down, there's already not enough light left for photosynthesis to function. An entire depth of ocean, from 200 meters to the surface, where sunlight still technically reaches, but plant life can no longer survive on it. Past that point, it only gets darker. By around 1,000 meters, there is no light at all. Not dim light, not shadows. Total, permanent darkness, every hour of every day, for the rest of the ocean's depth all the way down to 11,000 meters. Whatever lives past this point has spent its entire existence in a world with no concept of day or night, because there has never once been a sunrise. So now you have crushing pressure that distorts water at a molecular level and total permanent darkness. That alone should be enough to make this the most hostile environment on the planet. But there's a third problem down there, one most people never think about, and it might be the cruelest one of all. Near freezing cold, deep ocean temperatures hover just a few degrees above freezing, consistently, permanently, with no seasons and no warmth ever reaching that far down. And with cold, darkness, and crushing pressure all stacked on top of each other, there's a fourth problem that follows naturally: almost nothing to eat. Sunlight powers nearly every food chain on Earth's surface. No sunlight means no plants, no plankton blooms, none of the usual base layer that feeds everything above it. Whatever food exists at the bottom of the trench has to fall from thousands of meters above, scraps, carcasses, and organic debris drifting down from a world these animals will never see. Scientists call this slow, constant rain of nutrients marine snow. And at the very bottom of the trench, it's often the only meal available for months at a time. And here's how seriously humans have taken that danger. Only 3 people, in the entire history of our species, had ever reached the very bottom of this trench by the year 2012. And the reason why tells you everything about how hostile this place actually is. In 1960, two men, Jacques Picard and Don Walsh, became the first humans to reach the Challenger Deep, packed into a cramped steel sphere called the Trieste, suspended beneath a giant float filled with gasoline, because gasoline resists compression better than almost anything else available at the time. It took them nearly 5 hours just to descend. When they arrived, they'd stirred up so much sediment from the impact that they could barely see anything at all. And then, for the next 52 years, nobody went back. Not because we lost interest, because building something capable of surviving that pressure and returning intact was simply beyond what engineering could reliably deliver. It wasn't until 2012 that filmmaker James Cameron made a solo dive to the same depth, becoming only the third human being in history to reach the bottom of the trench. We've now sent more people to the surface of the moon than to the deepest point of our own ocean. Act 2, the impossible problem. Put all of that together, and you get an environment that fails life on every single front at once. Crushing pressure that distorts the water inside every cell. Total darkness, permanently. Near-freezing temperatures with no relief. And almost no food, arriving only as scraps from a world 11 kilometers above. On the surface, any one of these conditions alone would be considered a survival emergency. At the bottom of the Mariana Trench, all four exist simultaneously, all the time, with no exceptions and no escape. And yet, animals live down there. Not just survive for a few minutes like a diver testing their limits. Full lives. Hunting, feeding, reproducing, generation after generation, in a place that appears to violate the basic requirements for life as we understand them. So the real question isn't whether anything lives at the bottom of the trench. It's how something like that is even biologically possible. The answer starts at the cellular level, and it's more elegant than most people expect. Deep-sea organisms don't fight the pressure. They don't have thick armor or reinforced shells built to resist being crushed. That approach would take enormous amounts of energy in a place with almost nothing to eat. Instead, they've evolved to match it. Their cell membranes are built differently than surface-dwelling animals. Normal cell membranes would stiffen and become rigid under this kind of force, shutting down the basic functions a cell needs to survive. Deep-sea creatures instead have membranes built with different types of fat molecules, ones with small structural kinks that stop them from packing tightly together, keeping the membrane flexible and functional even under 1,000 atmospheres of pressure. Inside their cells, deep-sea animals also carry high concentrations of a stabilizing molecule called TMAO. Think of it as a kind of molecular shock absorber. TMAO surrounds the proteins inside a cell and prevents the crushing pressure from physically unfolding them, because a protein that unfolds under pressure stops working entirely, and enough of that happening at once is fatal. This is the same class of molecule, called a piezolyte, that's been found in nearly every animal recovered from the deepest parts of the ocean, including microbes pulled directly from the floor of the Challenger Deep itself. There's one more piece of this puzzle, and it explains why almost nothing that lives at extreme depth has a swim bladder, the same organ nearly every other fish on Earth relies on just to stay afloat. One quick distinction worth making: not every animal down there lives there permanently. Cuvier's beaked whales dive past 2,000 meters and stay for up to 2 hours, but they're commuters, not residents. Lungs built to collapse safely rather than resist pressure, blood loaded with extra oxygen for the trip down and back. That's a completely different strategy from what you're about to see. That's a temporary visit. What lives at the very bottom of the trench isn't visiting anything. There's one more piece of this puzzle, and it explains why almost nothing that lives at extreme depth has a swim bladder, the same organ nearly every other fish on Earth relies on just to stay afloat. Act 3, the reveal. Most fish control their depth using a swim bladder, an internal pocket of gas they inflate or deflate to control buoyancy. It works well near the surface, but gas is compressible, and at extreme depth, maintaining a gas-filled organ against 1,000 atmospheres of pressure would take a staggering amount of energy. Energy these animals simply don't have to spare, in a place where a single meal might not arrive for weeks. So evolution did something different. Past a certain depth, deep-sea fish either lose the swim bladder entirely or replace it with a different system built around oil instead of gas. Oil that barely compresses at all, giving them buoyancy without the losing battle against pressure. Every one of these adaptations, the flexible membranes, the stabilizing molecules, the shift away from gas-based buoyancy, belongs to one specific animal that represents the absolute limit of where a vertebrate can survive on this planet, the Mariana snailfish. It doesn't look like a predator. It's small, pale, almost translucent, soft-bodied, with an appearance closer to a tadpole than anything resembling the toothy monsters people usually imagine living in the deep. It has no scales. Its skeleton is only partially formed, more cartilage than solid bone, because a rigid skeletal structure isn't worth the biological cost at this depth. It looks, by every surface-level impression, fragile. It is the exact opposite of fragile. The Mariana snailfish holds the record for the deepest fish ever confirmed on camera, recorded living at depths beyond 8,000 meters, deep enough that if Mount Everest were dropped into that spot of ocean, its peak would still sit over a kilometer underwater. And it isn't just surviving down there in some minimal, barely clinging to life way. It is the apex predator of its ecosystem. At that depth, with almost nothing else able to function as a hunter, the Mariana snailfish sits at the very top of the food chain, feeding on small crustaceans and amphipods that share its extreme environment, which means every single adaptation this video just walked through, the pressure-resistant membranes, the molecular shock absorbers, the abandonment of a gas-filled swim bladder, isn't background trivia. It's the reason a soft, translucent, nearly boneless fish is able to rule the single most hostile square kilometer of habitable space on the entire planet. There's something worth sitting with here. Nothing about the Mariana snailfish looks equipped to survive extreme conditions. No armor, no obvious defenses, nothing that reads as built for battle. And that's exactly the point. Survival at the bottom of the trench was never about strength in the way we usually picture it. It was about a complete, total redesign at the molecular level. Every membrane, every protein, every organ rebuilt from the ground up to stop fighting the crushing weight of the ocean and instead exist in balance with it. But even this adaptation has a ceiling. Researchers studying TMAO concentrations across different depths have found something remarkable. The deeper a species lives, the more TMAO its cells carry, in an almost perfectly predictable relationship. And when scientists extended that pattern mathematically, the concentration needed to protect a fish's proteins at around 8,200 meters approaches the point where TMAO itself would make an animal's blood too concentrated to function properly, relative to the surrounding seawater. In other words, the Mariana snailfish isn't just an extreme example of survival. It may be sitting almost exactly at the theoretical depth limit for any fish with a backbone to exist at all. Every meter deeper than this, and the same molecule that makes survival possible would start working against the animal instead. The snailfish isn't alone down there, either. Sharing that same crushing depth are swarms of amphipods, small, shrimp-like scavenge, that gather in enormous numbers around anything that falls from above, stripping a carcass down in a matter of hours. They're the snailfish's primary food source, and they carry their own version of the same pressure-resistant biochemistry, proof that this isn't a single freak adaptation in one unusual species, but an entire ecosystem independently arriving at the same molecular solutions to the same impossible problem. Act 4, close. Scientists still haven't reached the absolute limits of what lies at the bottom of the Mariana Trench. Every expedition down there tends to find something unexpected, new species, new adaptations, organisms that shouldn't, by any surface world logic, be able to exist where they're found. Crude and robotic dives to the Challenger Deep remain rare and enormously expensive, which means there are almost certainly entire communities of life down there that no human has ever recorded. Consider the scale of what we don't know. We've mapped more of the surface of Mars and more of the surface of the Moon than we have of our own ocean floor. The most hostile, least explored environment on planet Earth isn't on some distant world millions of miles away. It's 11 kilometers straight down, underneath the same ocean surface that ships cross every single day without a second thought. And somewhere down there, right now, in permanent darkness, under more pressure than anything on the surface of this planet will ever experience. A small, pale, almost translucent fish is quietly going about its life, hunting, feeding, surviving generation after generation. Proof that the boundary of where life can exist isn't fixed. It's just wherever biology hasn't found a way through yet. Every one of the 4 conditions that should make life impossible down there, the pressure, the darkness, the cold, the starvation, has already been solved, quietly, by something most people will never see and most people have never heard of. The question worth sitting with isn't whether there's a limit to where life can survive. It's how many more of those limits have already been broken in a part of this planet we still haven't fully explored.